Alright, today we're going to learn how to find inverses of functions algebraically. What that means is we're going to be switching our x and our y variables, the dependent and independent, and then solving for the dependent, the y. They don't have to be x's and y's, but we're going to use x's and y's in this video. Another important thing is that when we find out the domain and range of the initial function, the domain becomes the range of the inverse, and the range becomes the domain of the inverse as well. That's an important step, and we'll see why later. Let's start off with our first function, this linear function, negative 5x plus 2. Well, the domain of this linear function is the domain of every linear function that's not horizontal or vertical. It's all real numbers. And the range of this linear function, again, is the same as the range of all linear functions that aren't vertical or horizontal. All real numbers. Alrighty, so that's going to become important later. Right now, it's just more of just to get in the habit of doing it. Alright, we're going to switch our independent and dependent variables. So we're going to end up with x equals negative 5y plus 2. And we need to solve for y. So let's see. Let's move this negative 5y to the other side to make it positive and subtract the x from both sides because the x needs to be away from the y. And then divide by 5, we get negative 1/5 x plus 2/5. There's our inverse function. So the inverse of f of x is equal to negative 1/5 x plus 2/5. This is the line that's reflected over the line y equals x. Alrighty, we also have to make sure we switch the domain and range, but because they're exactly the same, it's going to look exactly the same. Yay! Second function. This is a cubic that's been moved up 7 from the parent function. So the domain of this cubic is the domain of all cubics, all real numbers. And the range of this cubic is the same as the range of all other cubics, all real numbers. Again, just to get in the habit of doing that. Alright, so let's switch x and y. So x is equal to y cubed plus 7. We're going to subtract 7 from both sides and then cube root both sides. It's an odd root, so we don't end up with the absolute value of y. We just end up with y, cube root of x minus 7. So there we have it. The inverse of g of x is equal to the cube root of x minus 7. We would normally have to switch the domain and range, but because they're exactly the same, they're going to appear exactly the same. Alrighty. Let's look at the next example. We have a rational function, 1 over x plus 2. Here the domain and range is a little bit trickier. We're eventually going to learn how to find this, but for right now, just take my word. The domain of this function is just all values except for negative 2. We've studied that, domain restrictions. So this is negative infinity all the way up to negative 2, and then from negative 2 all the way to positive infinity. The range of this, well, the only y value this can't be is 0, because in order to get 0, your numerator would have to be equal to 0, and our numerator is 1. So we're never going to get 0. Alright, so negative infinity all the way up to 0, and then from 0 to infinity. That's the one value of y we'll never be able to get. Alright, let's switch our independent and dependent variable. X is equal to 1 over y plus 2. Alrighty, to solve this, let's pretend like this is you could either look at it like a proportion, so we're going to cross multiply y plus 2 times x and 1 times 1, or to clear a fraction, you multiply by the LCD, so multiply this side by y plus 2 and this side by y plus 2. Doesn't matter how you do it, you're going to get the same result. Y plus 2 times x is equal to 1. We need to isolate y, so we need to get it out of the parentheses, so let's distribute that x. Yx plus 2x is equal to 1, and now we can start isolating y, subtract 2x from both sides, and then divide by x. So 1 minus 2x over x is equal to y. Alright, there's our inverse function. H, the inverse of h is equal to 1 minus 2x over x. Now it's very important to take the domain and range and flip them. So the domain is now negative infinity to 0, and then from 0 to positive infinity. And the range is from negative infinity to negative 2, and then from negative 2 to infinity. There we go. That's the domain and range of this one. Again, this is something that will end up being true regardless. It's not necessary to make the inverse a real inverse, but you'll see in the next example that it does become important to include domain and range. Alrighty, so this looks like a square root function. Square root function does have a domain restriction. Remember, the inside has to be 0 or greater. In order to do that, that means that x would have to be bigger than or equal to 3. So this goes from 3 to infinity. And the range, because this is moved up 8, goes from 8 to infinity. Alright, this has become very important later. Alright, let's switch our x and our y's. Alright, so we're going to end up with x is equal to the square root of y minus 3 plus 8. So subtract 8 from both sides. X minus 8 is equal to the square root of y minus 3. We're going to have to square both sides. Keep in mind that when you square both sides, the whole side gets squared. So the entirety of x minus 8 gets squared. And when you square this side, you just get y minus 3. We're going to add 3 to both sides. X minus 8 squared plus 3 is equal to y. Alright, so there we have our inverse. Now we're going to notice something about this inverse in a second here. X minus 8 squared plus 3. This is a quadratic. This quadratic is a parabola, and that parabola fails the horizontal line test. So how is it possible for it to be an inverse? That's why the domain and range restriction is so important. When we carry this down, we're going to say that the new domain was what used to be the range of the original, from 8 to infinity. And the new range is the domain of the original, which is 3 to infinity. Now, what this does is this domain restriction cuts the parabola right down through the vertex and only looks at the x values from the vertex to the right. That is a one-to-one function because we've eliminated the other half of the parabola, which would cause the parabola to fail the horizontal line test. So in essence, this has become crucial. If I did not include this, then this function alone, x minus 8 quantity squared plus 3, is not the inverse of this. You have to include the domain restrictions because this is not one-to-one by itself. Okay? And another yet trickier example is this one right here. I have a quadratic which by itself would not be one-to-one, but we have a domain restriction that, again, this particular domain restriction cuts the parabola at the vertex and only includes the values of x to the left. So it actually is one-to-one in this case. Without this, it would not be one-to-one, and we could not find the inverse of it. Let's find the y values here. So the y values here, this is down 8, and then this opens upward, so the y values would be everything bigger than or equal to 8. Alrighty, I didn't use interval notation for this. This is inequality. Doesn't matter as long as the domain's in there. Alright, so let's switch x and y. We have x is equal to y squared minus 8. We're going to add 8 to both sides. X plus 8 is equal to y squared. And we're going to take the square root of both sides. But when we do that, we technically get the absolute value of y, causing the square root to have to either be positive or negative. Alright, we have an issue here because if I allow both the positive and the negative square root, we're going to end up with a sidewise parabola, which is not a function. So which one of these is it? Is it positive square root of x plus 8 or negative square root of x plus 8? That's where this comes in very handy, okay? So the new domain of the function is that x has to be greater than or equal to 8. Okay, so the new domain is that x has to be greater than or equal to 8. And the new range is that all of the y values have to be less than 0. So this goes from negative infinity all the way up to 0. Alright, now look at this. If we want my y values to be all negative numbers, are we going to do the positive square root or the negative square root? Hopefully you guys are thinking negative square root. That's what I'm thinking. So the inverse of k of x is equal to the opposite of the square root of x plus 8. That, again, helps us define which square root we're going to use. Like switching the domain and range becomes a crucial part of helping us find the inverse of the function. Okay, those are the tricky ones. Generally speaking, I'm hoping that you guys are comfortable with the process of switching your independent and dependent variable and then solving for the dependent to find your inverse.